Okay, good morning, class. We're going to be doing Geometry, Chapter 8, Lesson 2, Properties of Isometries. Isometries. We're going to start off with a comic strip. Where is my little mouse thing at? Oh, come on. Where's my mouse at? I can't find it. Oh, here it is. And I've lost it again. Alright, there you are. Now. Alright, we're going to start off with this cartoon. Separate checks, please, the guy says to his, I got it over here, to his own reflection. I wonder what that was. Could be that he doesn't realize that the man sitting at the next table, I don't know what that is his own reflection. Perhaps he doesn't want to pay for all he drinks because he was irritated by observing that the other person copied everything that he did during the meal. So here is something to think about. Suppose that one of those glasses in front of the man were still full, then its image in the mirror would be full. And if it were possible for the man to reach through the mirror and take a drink from the reflected glass, would it taste the same as the drink in the glass in front of him? The author to the book says the question is probably not. Then he goes into, oh, by the way, that in a book called The Ambidextrous Universe, Mirror Asymmetry and Time Reversed Worlds, there's a poem that's entitled The Age of Anxiety, in which a right-handed man sitting in a restaurant having a drink, just like what we just saw, and observing his reflection in a mirror, he says, "My deuce, my devil, my dear image, what flavor has that drink you lift with your left hand?" Notice the guy is right-handed. The reflection is your left hand. That's actually a lot of kids don't get that. My son, who is 16, of course you guys have met him, I think, Tim, he still does not get that. If we're facing each other and I raise up my right hand and he's looking right at me, I'd say, "Tim, what hand am I raising up?" And he'll raise up his left hand, which is on the same side as my right hand is, and he'll say, "Your left hand," when indeed I'm raising my right hand up. So that's actually a skill that kids actually have to learn. So there's a thing called stereoisomers. They're mirror image molecules. So we just talked about reflections. So these are like mirror image molecules, and they're inside of us. They're amino acids that are inside of us. They're alanine, if I'm saying that correctly, amino acids, and they're even called left-handed or right-handed. Here's a diagram of the chemicals. H is hydrogen, O is oxygen, C is carbon, and this is 3 hydrogens. So you see it's a total mirror image. These two line up, the 2 nitrogens line up, the hydrogens, these hydrogens here, hydrogens on the outside, oxygen and oxygen. These are double bonds. These are single bonds. It's just how they're connected. And this isn't actually like a drawing of them. You can see the 2 red ones are here. That would be the hydrogen. These would be the, I don't know what it would be. Oh, here it is. This is the carbon with 2 oxygens on it. Anyway, so you can see that they're mirror image. So just kind of talking about reflections and all that sort of stuff. So that was kind of interesting. So anyway, we're going to go into isometry now. Oop, I moved it. Isometries, they preserve 4 basic properties. That's distance, collinearity, betweenness, and angle measure. We already talked about in our last lesson how it preserved distance through a line. And so now we're going to show that how it preserves collinearity, betweenness, and angle measure. So First, we're going to go to transformation. This whole chapter is on, chapter 8 is all on transformations. And there's different kinds of transformations. So a transformation is a one-to-one correspondence between two sets of points. So changing the original size, shape, or position of a figure to create a new image. So when we had our line and we had, say we had a point here, a point here, and a point here, it corresponded to these 3 points here. The lines, this image, this A lined up to A prime. I called it 1 yesterday. I've now, well, the other day, I've now learned it's prime. And the measurements are still going to be the same. The angles are going to be the same. If you had 3 points, the collinearity is going to be the same. So transformation just means you're changing the original one here to create a new image. And so this is what we did in lesson 1 when we did the reflections. And at the top of your figure on page 275, you'll see an ABC there. And you'll see there's A, B, C, and then there's A prime, B prime, and C prime with the dots in front of them. Something like that. So the transformation theorem, actually we haven't got there yet, so that's what they're talking about. So look at that picture on your page and keep it there because we're going to be talking about that. An isometry is a transformation that preserves distance. That's the definition in the book. I'm going to show you a video in just a minute too. And the video says that it's a transformation where the original and the new image are congruent. And if you remember our reflections that we did, it showed that they were congruent. So that's a isometry. They're going to always be congruent. So since we showed in the last lesson that reflections preserve distance, which it says here, isometry is a transformation that preserves distance. Reflections are isometries. There are other types of transformations called translations, rotations, and we're going to be studying both of these in the next couple of lessons, not chapters, lessons. And then there's also another one that we're not going to be studying. It's called dilations. And here's a video that explains it. What?
Transformations in geometry.
Wait a minute, stop.
Basically.
Why is this not showing? All right, just a minute. Maybe I have to get that down. I think that might have been it. Okay, I think we can come to this now. Is that showing? I don't know why that's not showing.
What they are, changing an original size, shape, or position.
I'm going to stop this.